Okay, so we're going to look at some practice rearranging equations with an equation we haven't really used before. So the force required to extend a spring can be calculated using the equation F equals kx. So F is the force, K is something called a spring constant. Essentially, it measures how hard it is to stretch something. So a big spring constant means it's hard to stretch. And X is the extension itself. An extension means change in length or increase in length. So starting off with a few things we met before. So the standard unit of force is a Newton, or a capital N for short. The standard unit for an extension, or a distance, would be meters. Okay, so the first thing I want to do is rearrange the equation to make spring constant the subject. Okay, so here is our equation. So we want to get K by itself. So at the moment, K is multiplied by extension. So we're going to do the opposite of that. We're going to divide by extension. So we're going to have on the left-hand side, force divided by extension. And then on the right-hand side, that leaves K by itself, which is what we want. So then 3, use your rearranged equation to determine the unit of spring constant. So if spring constant is force, which is measured in newtons, divided by extension, measured in meters, that means the unit of spring constant must be newtons divided by meters, or newtons per meter. So we can logically figure out what its unit is, even if we don't know. Okay. So let's put this equation into some practice. So one particular spring requires a force of 20 newtons. So we've been given F in our equation there to stretch it a distance of 0.10 meters. So we've been given extension there. Calculate the spring constant. So we want to find out what K is. So here's our equation. Because we want to find out K, we're going to rearrange the equation to make K the subject. And we're going to do that by dividing by x, just like we did before. Now what we're going to do, because we want to actually calculate what K is, we're going to substitute some numbers into that equation. So F is 20, x is 0.1. So we get a spring constant of 200 newtons per meter. And what that means is it requires a force of 200 newtons to stretch this material by 1 meter, or increase its length by 1 meter. Okay, so if we move on to question 5, so another spring has a spring constant of 20 newtons per meter, and a force of 50 newtons is applied. So we've been given K, and we've been given F, and we want to essentially calculate what X is. So starting from the same point, this time we want to calculate X. So we're going to divide both sides by K, because that will leave X by itself. So we get F over K this time. So we've got values, so we can actually plug the numbers in. So F is 15, K is 20, and you'll notice both of those numbers have a common factor of 5, so we can divide that out. But we always express our answers in physics as a decimal, and it's a distance, so it's going to be in meters, so 0.75 meters. Okay, so moving on. So they're going to get a little bit harder. So this is one way we can make them a bit more difficult. So the spring starts off with a length of 0.2 meters. So we haven't been given what the extension is yet. We're just told how long it is, and that's going to be key. It's stretched by a 50 Newton force, so we still know that F is 50, so that its length is now 0.3 meters. What is its spring constant? So the first thing we're going to need to do is figure out what the extension is. Because if we want to calculate K, we're going to need F and we're going to need X. But we haven't been given X, but we've got the data to work out what it is. So the extension is the change in length. So it started as 0.2 and it's now 0.3. So it's been extended by 0.1. Now we've got X, we're in a position where we can do some calculations. So we want to calculate K, so we can divide both sides by X. We want to calculate the value of K, so we're actually going to plug our numbers in. So we're going to do 50 divided by 0.1, and that comes out as 500 newtons per meter. Moving on to question 7. Again, there's a tricky little difficulty in here we have to address. So we've got a spring with spring constant of 40 newtons per meter. So that's K is 40. That's not a problem. How much force is required to stretch it by 10 centimeters? So that's x is 10 centimeters. Now, before we can use an equation, our distance must be measured in meters. So the first thing I'm going to do here is convert the distance into meters. So the thing you have to know is that 1 meter is 100 centimeters. Once you know that, we can now figure out what 10 centimeters is. So if we divide both sides by 10, we can see that 10 centimeters is 0.1 meters. Okay, now we have that, we're in a position where we can calculate the force. So we don't need to rearrange it because F is already the subject. So we can just plug our numbers in. So 40 times 0.1, the distance has to be in meters to go into an equation or it will give you the wrong answer. And that's clearly 4 newtons. So last question before we get to the extension section. So we're going to have 2 unit conversions in here, making this a little bit trickier. So we've got a force of 20 kilonewtons. So we've got F, and we've got it extends by 200 millimeters. So we've got X, and we want to calculate what K is. So we're going to need to do a conversion with both of these because this one on the left, the force, has got kilonewtons, and the distance has millimeters. So let's address kilonewtons first. So the thing you have to know is that 1 kilonewton is 1,000 newtons. So if we want 20 kilonewtons, that's going to be 20,000 newtons. So it's a really big unit of force, a kilonewton. So we're going to start meeting these quite a lot. So these letters you can see before the unit are called prefixes. So you can see we've used a K, which stands for kilo. And what that tells you to do is multiply by 1,000. So you can see you take the number 20, times it by 1,000, and you see you get the 20,000 that we already calculated. So if you see a K, that's telling you multiply by 1,000. It's the same thing with other things. So 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters. The kilo always means 1,000. Okay, so 200 millimeters. So again, the thing we have to know here is that 1 meter is 1,000 millimeters. Now, how do we know that? Well, 1 centimeter is 10 millimeters, and 1 meter is 100 centimeters. So that's where that's come from. So if we want to know what 200 millimeters is, if we divide both sides by 5, that tells us what 200 millimeters is in meters. So this milli is another prefix. So the milli indicates divide by 1,000. So kilo means multiply by 1,000. Milli means divide by 1,000. So 1 milligram is 0.001 grams. We've divided by 1,000. 1 millimeter is 0.001 meters. So you can see what we need to do is take the 200, divide it by 1,000, and you see that comes out as 0.2. Now we've got our force and our extension, we can calculate the spring constant. So we rearrange it to make K the subject. We can now plug our numbers in, and we get that the spring constant is 100,000 newtons per meter. Okay. Having a look at the extension problem, great if you've managed to give this a crack. So we've got an equation to calculate the energy stored in a spring when you stretch it. So we want to know what the extension is with a spring that has a spring constant of 10 newtons per meter, so that's K, when it has 5 joules of elastic potential energy stored in it. So that's telling us EPE, if you like, in the equation is 5 joules. So we want to calculate X. So the first thing we need to think about is we need to get X by itself. Okay? So that's our objective. So I'm going to do this step by step. So the first thing I'm going to do is multiply both sides by 2. That gets rid of the half on the right hand side. Then what I'm going to do is divide everything by K. That leaves us just with X squared on the right hand side. And then to get just X, we're going to square root both sides here, because that would leave us with X. So you can see to calculate x, we're going to need to do 2 times the elastic potential energy, divide by the spring constant, and then square root that answer. So let's do that. So we're going to do 2 times 5 divided by 10 and then square root of all of that. And that's nice and easy. It's the square root of 1, which is 1 meter. So to store 5 joules of energy, we're going to have to stretch it by 1 meter.